Hello everyone, so in this tutorial we're going to learn how we can build a circuit diagram based upon a state diagram. Okay, so this is the state diagram. We have to build a circuit diagram based upon this state diagram. Okay, so from this state diagram we can clearly see that there are four different states: 0 0 0 1 1 0 and 1 1, and we can say that if the present state is 0 and if the input is 0, then the next state would be 0 0, right? You can see the arrow right here, so it's coming back to 0 0 again. So that means from present state 0 0, if the input is 0, then the next state would be 0 0 again, and there is no output because there is no slash notation here. Okay, so from 0 0, if the input is 1, then the next state is 0 1. So this arrow suggests that if the input is 1 and if the present state is 0 0, then the next state would be 0 1. Alright, so this is the state 0 1. So from 0 1, if the input is 0, then the next state is 1 0. Alright, and if the input is 1, then the next state is 0 1 itself. Alright, so following this procedure we can find out the next states for all the present states, right? And we can create a table which would look something like this. Okay, just like what we did a few moments ago, that from present state 0 0, if the input is 0, then the next state is 0 0. If the present state is 0 0 and if input is 1, right, if input is 1, then the next state is 0 1, right? So this is the table that we can build just by looking upon this whole diagram. Okay, so this is the first part that we need to do. So once we're done with this, next we need to figure out the flip-flop inputs. Okay, and to find out the flip-flop inputs, we first need to look at the question and see what type of flip-flop can we use in this question. All right, so in this question we're supposed to build the diagram using JK flip-flop. Okay, so we need to use JK flip-flop, and there are four different states, right? 0 0 0 1 1 0 1 1. So that means there are 2 to the power m number of states. So we have m number of flip-flops. Okay, so we'll need m number of flip-flops since there are 2 to the power m number of states. So there are 4 states, right? So basically 2 to the power 2 number of states, so we'll need 2 flip-flops. Okay, so 2 JK flip-flops, so that means 4 different inputs. And since there are 2 JK flip-flops, and in JK flip-flops the inputs are regarded as J and K, so that means for both flip-flops the inputs could look like JK and JK, and to distinguish amongst them we can just name them as JA, KA and JB and KB. Alright, so these would be the 4 inputs of JK flip-flop. Okay, and there is no output here. Okay, again there is no output. So now we need to figure out the flip-flop inputs. Okay, so we'll create 4 separate columns for flip-flop inputs. So these are the columns of flip-flop inputs. Okay, JAKA and JBKB, and to fill those columns up we need to take help of the excitation table of JK flip-flop. Okay, this time we need the excitation table. So when we converted from circuit diagram to state diagram, we needed the truth tables, but when we convert from state diagram to circuit diagram, then we need the help of excitation table. So this is the excitation table of JK flip-flop. Okay, so here at first we'll write down the values for JA and KA, and if we want to write down the values for JA and KA, then we need to check only A and A plus, and when we calculate JB and KB, then we need to look at B and B plus. So that means when we calculate JA and KA, we only need to consider everything regarding A, and when we calculate JB and KB, we need to consider everything regarding B. Alright, so here we want to write down the flip-flop inputs. So we will look at the present state and the next state, so A and A plus. Okay, so at the first row we can see that the present state is 0 and next state is 0. Then we go back to the excitation table and we can see if the present state is 0 and the next state is 0, then J would be 0 and K would be don't care. Okay, so we write down J is 0 and K a don't care. The next row would be the same, and for the third row we can see present state is 0 and next state is 1. If present state is 0 and next state is 1, then j would be 1 and k would be don't care. Here we can see ja is 1 and ka is don't care. So let's take an example for a very random row like this one. So the present state is 1 and the next state is 1. So we go back to the excitation table and we find out those combinations that present state is 1 and next state is 1, and then j and k are don't care and 0. So here ja is don't care and ka is 0. So we just filled those columns based upon the excitation table of jk flip-flop. Similarly, we can do the same stuff for jb and kb, and we will only consider b and b plus as present state and next state for that, and we will take the flip-flops excitation table into consideration, and we will fill those columns up. Okay, so this is how we can fill the flip-flop input columns. So once we get all the values, next we'll build some k-maps. So we'll build k-maps for the flip-flop inputs, and if there was an output in this circuit, then we would get another separate column like for that output, and we would build the k-map for that output too. But here we don't have any output, we only have flip-flop inputs, so we'll need to find out the k-maps for all those inputs. Alright, so there are 4 separate columns, so that would be 4 k-maps. So here you can see that we have built 4 different k-maps for JAK, JB and KB, and the inputs of those k-maps would be the present state and the external input. Okay, present state and the external input. So 2 present state and one external input, so 3 variables. So 3 variable means there would be 8 squares in the k-map. Okay, and it's a 3 variable k-map for all the input columns. All right, so here you can see the the k-map for JA, here's the k-map for KA, and here are the k-maps for JB and KB. Okay, so just draw the k-maps and put down ones and don't cares as usual, and just do the groupings and find out the equations. So if you have trouble calculating the k-maps, just see my lectures on k-maps, and that should be cleared up. Okay, so I'm not explaining k-map here any further. So once you are done with the k-maps, you will get 4 different equations, and based upon those equations you can actually draw the circuit. So these are the equations, and now you need to build the circuit. Okay, so remember in the actual diagram we had 4 states, so we calculated that we needed 2 flip-flops. All right, 2 JK flip-flops, since the question asked us to build it using JK flip-flop. So I drew 2 JK flip-flops, so one with the output of A and another with output B. So the first inputs would be J and KA, and the inputs for the second flip-flop would be JB and KB. Here we need X as external input, so I have also created a connection for X. So the first equation here is JA equals to BX prime. Okay, so here is B, so I'm just gonna take a connection from B and X prime, so that means I need to use a NOT gate. So this is X prime, and those two would be joined in an AND gate, and then the output would be connected to JA, right? Then KA equals to BX. Alright, so this is X and this is B, right? So I can just use an AND gate to connect them both, and then connect it to the KA part. Then JB equals to X, so X can be directly connected to JB, and finally KB equals to A X NOR X, right? So X can come from here, and A is available here, so I can just take a connection from A, and then I can just use an X NOR gate. Alright, this is an X NOR gate, and then I can connect it to KB. Alright, so this is the whole circuit, and this is the final circuit that we are trying to derive from the state diagram. Okay, so I have drawn the circuit in a vertical manner, but if you wanted, you could actually draw it horizontally. Okay, so this is one way of drawing it, and I'm showing you the other way within a few moments. Okay, but yeah, this is the final output for this question. All right, and if you wanted, you could actually draw the circuit using this horizontal manner. Okay, so it's the same stuff. So it's basically you just need to care about the connections. It doesn't matter whether you put the flip-flops vertically or horizontally. Alright, so this is the final outcome, and that's it for this question. So hopefully you all understand how you can build the circuit diagram from state diagram now. Okay, so thank you very much.